Okay, what do we have? I've got two 6805 LLB bearings from my Hambini bottom bracket. I had problems. I inflicted the damage on them. That's why I had problems. Has nothing to do with Mr. Hambini's machining excellence or design brilliance. Anyway, 6805 LLB, what's that? 6 is a designation for the type of bearing it is. In this case, it's a deep groove cartridge bearing. 8 is a diameter series. It has a corresponding width series that goes with it. In this case, we're talking about the width of that bearing, that dimension there. A 7 would be smaller width, a 9 would be slightly larger width. The 05 is a singular code. I go through this in more detail in a lengthy video on my examination of these two bearings performed yesterday. But I only examined the exterior. I had not removed the seals. Today I'm doing that. 05 is a designation for the bore diameter. In this case, it's a 25 millimeter. I've got a 24 millimeter axle that goes through here. Delrin sleeve pops in there. The axle goes through. The Delrin sleeve takes up the extra space between the 25 millimeter opening and the 24 millimeter wide shaft that's this thing is going to be mounted on. So anyway, those are the damaged bearings. This one is a drive side bearing. You can see it actually still spins around, but it's notchy. When I had the axle in there, when I examined it after I discovered the damage, I could feel it notchy. It's not so notchy in my hand, but there's no real load on it. So I think I could probably reuse that for something else. I wouldn't put it back in my bottom bracket. This one is the non-drive side, and this is the one I had a real problem with. It's absolutely frozen. It won't move. You can put a lot of force on there. It won't move. So I explained in a separate video how I inflicted this pain on my bearings. And what I reordered the bearings. That's what this box is. I got it from the dealer in Bangkok. It's an authorized dealer. And I explained in my other video how you can be sure of doing that and how you can be sure of not getting a fake. In fact, how you can examine it yourself. If you're standing in a shop buying this, you still can't be sure that a local bike shop hasn't got a bunch of fakes. He doesn't know. It's hard to spot. Hambini has mentioned they make good fakes, but it's what's on the inside that counts and how they perform. So I talk about all of that. But what I discovered when I did the detailed exam yesterday is there's all kinds of information printed on the seal itself and also on this outer edge. Now you can imagine how small the stamp is that goes on there. I don't know how they do it, but people do amazing things. Anyway, it's a lot of information. And on the seal, just to summarize it, it says NTN, Japan, and it has the part number for the seal, which is 6805LB. Now, that's just the part number for the seal. It takes 2 seals to do this, and it takes all of these other components to build the finished part. The finished part number, 6805LLB. LL signifies it's 2 seals. If you get a 6805LB, which I don't know if they even make them, but that would mean it's a bearing that only has 1 seal. Alternately, you can get, these are non-contact seals, and I'm going to explain how that fits in here because I didn't do it yesterday. And I've taken the seals off. They're not hard to get off, but you get them off by pulling on the edge of the seal on this edge and getting under it, and then it'll come right off, and you can put them back in. This stuff is probably made out of Delrin, which is a really cool material. You can read about it. It's all Delrin's trade name. You can read about it. It's also called POM. Might also be called acetal, if I'm remembering correctly. Anyway, it's a superior type of plastic material that's very durable, and it has this curious property of self-lubricity, which means it doesn't really require lubricant. Although these are hydraulic fittings, it's meant to keep water and crap out, but just as importantly, it's meant to keep the hydraulic material, aka grease, inside. So how this works, I examined this. There's a little, the contact seal, non-contact seal does not contact the outer or the inner race. This is the moving part of the bearing right here. All right, this thing moves around. The bearings will move around, but this is the moving part. The bearings are not locked in place as they are now. But this is the moving part. So anything that comes into contact with that is going to create friction, which will create heat, which adds drag, okay? So it has a specific application when you have a contact seal. And the contact seal will actually make contact with the inner race, all right? And that's how it creates a more weather-tight seal. And usually with non-contact seals, this non-contact seal, it's made to be used with a bearing that's going to have grease as a lubricant. That's what non-contact seal bearings have, and that's because grease is kind of, it's going to aid in keeping crap out, I guess, a little bit. But the seal is not a full seal, so shit can still get in there. And if you're riding around in crappy conditions, you might want to look into a 6805 LLU, which should be a double sealed contact seal, in which case that contact seal will come in contact with the inner race, will create some friction and heat, but it's going to do a better job of eliminating ingress of water, dirt, and other contaminants into here, which is the critical part of a bearing, right? So how does this non-contact seal work? How does it go in there? Well, there's a lip right here, right under the top edge of this ring. There's a lip, and that lip provides a groove between the top part of the ring and the top part of this, which is actually helps define the groove that the bearings run in. Remember, this is called a deep groove ball bearing. Well, look at how deep that is. That goes in there. Doesn't go in there much here, or I can't get my tool in there, but I don't know, maybe it's about the same. I would imagine, yes, it is. It's just it's harder to get this tool in here. This lip here, the bearing on this side will snap into that groove around here, and into the outside of this seal will snap into that and stay in place. All right. But when it snaps into this side, this thing is designed so that this edge is never actually in contact with this at all, so that this will spin around without creating extra heat and friction. So this has a specific application, and so does the one with the contact seal. It's not one is better than the other. One is better for a specific use than the other. All right, and that's all there is to it. So that's how these things go in there. Now, the bearings themselves are born in a steel cage, not a plastic cage. That's a steel cage. All right, and you can see the bearings much better on this side than from this side. That's what it looks like to me. That's grease coming out of there, not dirt. These bearings only have about 500K or a little bit more maybe on them. So it looks like the bearings are a little bit more prominently on display here. Now those bearings will roll around inside this cage, but this is the actual moving part of the bearing, okay? So that's going to kind of roll around with the balls supporting it. So I don't know how this part is assembled. It doesn't pop right out. And it's the same thing on either side. There's a lip for the inner part of the seal to snap into, and a lip for the outer edge of the seal to snap into. So these two things are the exact same part. This part here, the inner race, looks to be designed exactly the same from either perspective. And this piece here looks to be the same. So how do they get the cage and the balls in there? Well, you could take this part out and the cage is not going to fall out because there's that lip on both sides of the outer ring and the balls extend in there. So maybe there's a little bit of flex to the steel cage, maybe. And this part seems to be what would be the final part to be added when you're assembling just this piece. Obviously, the seals are the last thing that go on. So what's the assembly process? You've got the outer ring and race. You've got the cage with the balls, and you got an inner ring. So you take the outer ring, you put the cage with the balls, and you can probably snap it into place. And then this piece, pop it into place. That's what I'm thinking. I can't think of any other thing. And I don't think it probably takes much pressure to do that. Now the question is, and these bearings are shot, so I don't mind fucking with it. And I probably will take it down to the shop and see what is involved in getting this out. Now, how did this bearing freeze up? Don't know. But it almost looks like it's out of round. I mean, am I imagining things? It kind of looks a little oval, like this dimension is a little greater than this dimension. Don't know. I'd have to put that down and really look at it. Hambini can probably tell me right off the top of his head, well, this is what caused it. Well, I know what caused it. It was a lot of force being applied from the outside of the bearing when I tried to push that bottom bracket in when it just wasn't going to go in. So I gave it a lot of oomph to try and see if it go in. No, ladies and gents, it would not go in. And in the process of doing that, I put some damage there. Furthermore, my bike shop, when I had them take a look at that, one of the things they did was remove the bearings, and they used one of those things to drive them out, which is not good. And I talk about that and why Hambini says it's not good. So I'm not going to reiterate it. But how did it freeze? What did I do? And is there some other damage to my bottom bracket yet to be discovered? Well, I'll soon find out, because I put some ceramic bearings, because that's what my local shop had in it, because I wanted to ride, and I'm testing it. I'll see if it craps out those bearings. And if it does, I think I got some other problem, something with the, can't imagine it's the axle at all, but something I damaged to the bottom bracket when I was putting it. Who knows? We'll find out. If it's fucked up, I'll just fix it. I'll unfuck it. That's what happens when you're learning on the job. So anyway, that's the examination I did yesterday. You'll see the detailed video for that, and that's the examination I just performed today. Now, this is where you're going to grab that seal, go in like that and under, and then you can get your tool under there and it pulls right out. Now this has been in and out a few times, and you think, okay, maybe that's going to damage it, but I don't think so. Like I said, Delrin, I think this is probably Delrin. It's tough material. So it's made to come out and it's made to go back in. And you just kind of pop it back in like that, and there it is, ready to go again. Now I think this, it's a fucked bearing. I won't use it for anything important, but who knows? I wouldn't get rid of this. At least it's a point of reference, and the seals could be reused if nothing else. So that's that. Now, the new bearings I got from Bangkok. I did the world's worst unboxing video, which is attached at the end of a different segment to this. And I never actually got this on camera. So now I'm doing it. Let's take a look at the box first of all. Came from the machine company in this box. Obviously it's big enough. Maybe this is how they buy it. They probably buy it with 10 pieces per box, and there's 10 of these or 12 of these in a case. That's probably how companies buy it from the factory. Factory's not making it and putting them on a shelf like this. They're putting them in a box like this, in another box that's made for shipping to some distributorship, sealed, put on a shelf in the warehouse until somebody buys them. Now, the curious thing I found about the examination here is all the data that you can glean from this, that you might be able to determine this is a fake or the real deal if you look at that. So you can watch that detailed video of my exam of the exterior of this bearing and learn all about that, because I think one of the points of focus of it is how to avoid buying a fake. And the simplest way is mentioned prominently in that video. But there's also this data on this ring, very hard to see. Need a magnifying glass and a good light. And it's still hard to see, but I did see it, and I know what's on there. And I think what's on there is a date code, because one of these says 200206, and then it has a lot number. I think it's a lot number, date of manufacture, and a lot number for the manufacturer. Okay, and the other one of these spent bearings says 200409 and a different lot number code after that. It also tells you the Japan, NTN, and the part number for this piece there, 6805. It's stamped right on the edge. This part number, 6805LB, it's right there. It also says NTN and Japan on here. Now, a good counterfeit one might actually say all that stuff on the seal. That's easier to do. The stuff here on this rim, I don't know. I think that would be an awful fine counterfeit piece. So you might be able to look at that if you're in a shop and you have it in your hand, but you're going to have your reading glasses on. I can see it in a certain angle in the light, like I can see that information there. Okay, there's more there. There's more there. Okay, I can see that, but it's hard to see. Anyway, no, I was interested to see, okay, what about these? Does it have the same information? Does it have perhaps Thailand stamped on here instead of Japan on the outer ring? And I opened this up and I examined it. And no, it doesn't. It has the exact same information on the outer ring as the other bearings I got out of Hambini's bottom bracket, except this one says 20017 with a month code. I forget what it is. And I definitely think that these are date codes. So you wonder, well, what's Hambini putting, well, 19-year-old bearings into my bottom bracket for? Well, I don't think it makes a damn bit of difference. These are durable, good bits, properly manufactured, quality grease in there, sealed, put in an airtight, watertight package, into a little box, into another box, into another box, and on a fucking shelf in the warehouse, and there's nothing going to happen to that. Furthermore, that warehouse at the plant ships it to distributorships when they get an order, and they're not going to break a case. They don't do that. They send the whole case. So how many is that? Maybe 100 in a box like this to the distributor. They're going to sit on his shelf until he sells them. Who knows how long that takes. Anyway, point is, this is right from the distributor. It's 4 years old. I haven't even looked at this one. I don't really want to. It could say 2015 or 2019 for all I know. But I think that's confirmation of the fact that I was wagering that that's a date code. The other interesting thing is there a side-specific, direction-specific way to mount this bearing? Can it go in either way, or can it go in only one way? And if so, which way? Well, I don't think there is. I think it's probably exactly the same from either perspective. The only thing I would say is one side of the ring has information and codes stamped on it. So I can see it right there clearly. The other side has no information on the ring. So if you mount it so that the information side is into your bearing cup, you don't have access to that information, do you? Not that that would necessarily be all that important, but you never know. I would mount it with the side that has no information stamped on that ring to the inside. Now, Dr. Hambini might say, no, George, there is a specific direction you have to, but I don't think so. When I pull these out, I look at the wear on here, and that's all gone over in deep detail on my other video. I look at the wear on these, and it looked to me like the Delrin sleeve is leaving some discolored marks on one side, because it's not discolored on one side, and there is some discoloration. Let me get that back in there. There is some little discoloration on now you can see it there. But not on this side. So the Delrin sleeve fits down in there, and I'm wagering the Delrin sleeve fit in from this side, and it left some discoloration on there. Anyway, there's more information on my other video, because it's curious, the look of this race and the look of this race. You can watch that video and find out what I'm talking about. Anyway, So there's the actual unboxing of the video of the bearings for you, kids. I hope you enjoyed that. I had a good time examining this yesterday and trying to teach myself a little bit what the fuck about bearings. And it's something I need to know. So I kind of dove in deep, and you can find out all about it in that other video. This one's done. Thanks for watching.